Today we're going to look at inverse trigonometric functions. So we're going to look at the sine function first, then we're going to look at its inverse. What can you tell me about the sine function? It's a wave, starts at and heads up. Very good. Y equals sine of x. Do you know what the domain of the sine function is? Okay, if you look at the graph, can you tell what the domain is? Domain is all the available x numbers. Negative infinity to infinity. Nice job, you guys are smart. Range is the possible y values. And we have arc sine. Y is equal to sine inverse of x, or y is equal to arc sine of x. Yes, it's like the archangel. Today we're going to do archangels in mathematics. No. So y equals sine inverse of x and y equals arc sine of x are the same things. Right now, as Maya is listening in, she's recognizing, oh, we needed to know that in calc. I forgot that we even did that pre-calc. Is it fair to say that when you get to calc, we forget about this lesson, right, Maya? It's pretty normal. I'm not picking on you by any means. That's just kind of how it goes. So I would like to look at the inverse function. Now, do you remember first semester when we did inverse functions? We said y is equal to 2x plus 4. Do you remember how we came up with the inverse function? We said x is equal to 2y plus 4. We switched the x and the y values and we solved, didn't we? We said that the domain becomes the range and the range becomes the domain. So in this situation, the new domain is going to be from -1 to 1. Exactly. Yeah, okay, so the Alex's are absolutely correct. Hence, she says you flip it sideways. To be a little bit more exact, we're going to flip it over the line y equals x. And when you do, you get this type of shape. Now, here's the problem. Is that a function? No. And you maybe remember, in order for us to find inverses, the original function had to be 1 to 1, meaning it had to pass the horizontal line test. Does the sine function pass the horizontal line test? No, in fact, I would have to cut it. I would have to cut it, say, here, get rid of that stuff, and cut it here and get rid of that stuff. Does the green function now pass the horizontal line test? So we just flip that portion. And I'm going to show you what it looks like on the calculator, because we actually have the ability to look at the inverse sine function. I go second sine inverse. I'm going to make sure I'm working in radians, and I'm going to zoom standard. And you're not going to get anything real special right away, but that's all you get. And if I zoom in on that as a box, kind of check this thing out. Press enter there. And press enter there. And that's what we get. So it's just that small segment reflected. And so it goes from -1 to +1 for the x values, but the y values actually go to +π/2 and -π/2. Starts like this, and it goes like that. That'll be the graph of arc sine. Can you tell me, when do you choose to press the second sine or arc sine button on your calculator? When do you choose to do that? When you're trying to find the angle, right? And so arc sine will produce values. Look at the range. It will produce values from -π/2 to +π/2. So as Jackson said, we use that when we're trying to find angles. It will produce angles between -90 degrees and +90 degrees. That's what it will do. That's what it's determined to do by this graph. So I need somebody to give me a number for to plug in between -1 and 1. Jaden, what do you got? Between -1 and 1. 0. Great. I get 0. That was fun. Let's try something else. 0.5. You all know the inverse sine inverse 0.5 is 30 degrees. Michaela? 0.866. Great, you're going to get about 60 degrees, right? We all know that. John, what are you going to do? Sine inverse of 0.7. Okay, so you get 44 degrees. Somebody give me a negative value. Negative 0.69. And we get negative 43.63 degrees. Look, it's always coming up with values between negative 90 and positive 90. But if I dare try sine inverse of 1.5, you can't take sine inverse of a value outside of the domain of negative 1 to 1. Good. Cosine function. What's different about the cosine function? Yeah, it starts up at the maximum. But its domain and range are the same, aren't they? Domain is from negative infinity to infinity. And the range is from negative 1 to positive 1. So arc cosine, its domain is also going to be negative 1 to 1, but its range, if I just kind of check this guy out again, I'll go second arc cosine. Hey, come on. And then mode, we go back down into radians, I press graph, and we'll see what we get. I kind of have to go a little bit higher, don't I? Yeah, if I go into my window and I take my y max instead of 1.9, I'm going to go up to say 4. I'll try that again. What do you notice about this graph? It's always above the x-axis. It's always positive. And it actually goes all the way up to a value of pi. It crosses the y-axis at pi over 2. And this is what the graph looks like. That's the graph of arc cosine. Notice what the graph is saying. Does anybody remember what the cosine of 180 is? Negative 1. And that's why arc cosine of negative 1 is 180 or pi. Does anybody know what the cosine of 90 is? 0. That's why the cosine inverse of 0 is pi over 2. So on and so forth. So this maps to exactly what we want. It's always positive. So the range is from 0 to pi, which means that it's going to always spit out values between 0 degrees and 180 degrees. So this kind of gets a little bit more fun. If I go into my mode and I switch it on over to degrees, and I go second cosine inverse, somebody give me a value between negative 1 and 1. Jada, what do you got? Between negative 1 and 1. 0.8, and it gives me a value of 36. Somebody else. 0.69, I get 43. What'd you say, Emma? 0.76. Okay, I'm getting out these. What if I plug in some negatives? Cosine inverse of negative 0.5. I get 120 degrees. So you do cosine inverse. What'd you say? Negative 0.99. Great. And I get you made it through the more difficult part of the lesson. Good job. So we're not going to do arc cosecant and arc secant, arc cotangent. You really don't need to know those. But I am going to look at the graph of tangent of x. And I'm sure all of you remember from your chapter 5.3 through 5.4 test that the graph of tangent has vertical asymptotes and that it has that general shape. And so we're going to consider that section of the graph to have a domain of negative pi over 2 to positive pi over 2, and that the range is going to be all real numbers. And so therefore, the domain for arctangent, or tangent inverse of x, is equal to negative infinity to infinity. And the range is going to go from negative pi over 2 to positive pi over 2. I don't know if you can kind of think about this graph of arctangent of x, or tangent of x, and if you have vertical asymptotes, and over here you're going to have horizontal asymptotes, pi over 2 and negative pi over 2. And then you're going to flip that. So you're going to take that graph and flip it over the line y equals x. Yeah, you're going to get that kind of a graph. So as you draw that, I'm going to pull it up right here. And y equals, and I'll go tangent of x, or arctan of x. I'll zoom standard. And you can see, there it is. Yeah. You know, if you want to change the window and go say x and -6, +6, and then your y values just go like -2 and +2, you might get, you know, a graph that looks a little bit more kind of like what we have, something like that. But that's arctan. Okay. So if I go into mode and I select degrees, it looks like I can take the arctan of any single number I want. Arctan at 256, 89.77. What do you got? Arctan of 52 pi. Again, you're getting an angle around 89. Why am I getting values close to 89? I mean, if you try like arctan of 500, you get like, 89. What's going on? Yeah, it can't be 90 because the tangent of 90 is undefined, right? So if you take the arctan of large numbers, it's going to approach 90. So let's say you did like, I don't know, whatever that is. Of 12? Very good. 85. And if you get arctangent of, say, of 1, you get 45 degrees, right? Arctan of -0.5, I think we're getting about -26 degrees is going to be my call. Yeah, we do. Okay. The arctan of wow. There you go. Again, the arctangent of 1 is 45 degrees. We know that one. If you do the arctan of the root of 3, you get 60 degrees. Everybody knows that that's going to be 60. Right? So even though we say that, it can never be 90, the fact is if we type in a bunch of zeros, we create a very large number. So we're approaching my bank account right now. And press enter. That's where, again, the calculator is wrong because it's not 90. It's going to be less than 90, but it rounds it, yes. Nope, because you're laughing about it, so I'm not going to type it in. All right. So you guys are fortunate in fourth hour because you're able to see some things that we didn't anticipate in the other classes. And in order to understand these problems, I've begun to understand that you need to know these three triangles. And so we have these 30, 60, 90 triangles. We're going to determine arc sine, arc cosine, arc tangent of different values. And hopefully some of you have been able to ingrain this in your brain. But in this case, this triangle for 30 degrees, you get the sine of 30 degrees ends up being the y value, which is a half. And the cosine of 30 degrees ends up being the x value, which is the root of 3 over 2. And the tangent of 30 degrees ends up being y divided by x, which ends up being the root of 3 over 3. Do those values look familiar to you? And for some of you, you've known them so well that you don't even need to write these down. You've memorized them. Good for you. Others, you maybe need to kind of take a glance at them. We have a 45-degree triangle. And the sine of 45 degrees is what? Root 2 over 2. Cosine of 45 is root of 2 over 2. And then the tangent of 45 is 1. So it looks like the 45 one was pretty easy. And then if you just do another one that's a 60, 30, 90, hopefully you can start to see it's not that bad to memorize all of these. What's the sine of 60 degrees going to be? Get rid of 3 over 2. And then the cosine of 60 degrees is going to be a half. And then the tangent of 60 degrees is going to be just the square root of 3. So Brooke is very intelligent. She already knew all that. She's been teaching Kayla, and so good for you. So let's understand what your calculator is able to come up with and why it does. The tangent inverse of 1/2. What kind of triangle would give me 1/2 for sine? Yeah, as you can see right here, you have the 30-degree angle. Now there's two spots where sine is equal to a half. That's a 30-degree angle there and a 30-degree angle there. Didn't we just do that when we solved for angles earlier? So you get 30 degrees here and 30 degrees here. So that's 30 degrees or it's 150 degrees. Tell me, which one will my calculator produce for me, 30 or 150? It will produce 30 because arc sine produces values between negative 90 and 90. So because it chooses values between negative 90 and 90, you get 30. Arc tangent of negative 1. Where is tangent equal to negative 1? Well, what kind of triangle is going to give me tangents equal to 1? A 45. And where's tangent negative? Second and fourth quadrants. Very good. Well, one of these is 135 degrees, and another one is 315 degrees. And it says that arc tangent has to be between negative 90 and positive 90. Are either of those between negative 90 and positive 90? Neither one. So can anybody guess what I'm going to get if I do arctan of negative 1? What'd you say? Yeah, negative 45 degrees. Isn't negative 45 degrees the same as 315? That's why it produces negative 45, is because of the arctan function. Okay, so that's what we get. Can cosine ever be 3? No, if you look at our domain for arc cosine, domain is negative 1 to 1. You have to plug in values between negative 1 and 1. So in this situation, it's undefined. Finally, cosine of negative root of 3 over 2. What type of triangle gives you cosine is equal to root of 3 over 2? That 30-degree triangle, right? So 30-degree angle is going to give you that root of 3 over 2, but it's negative. Cosine is negative in the second and the third quadrant. So that's 150 degrees or 210 degrees. Can you tell me, is arc cosine going to give me 150 or 210? Why will it give me 150? Has to be between 0 and 180. So therefore, the arc cosine of negative root of 3 over 2 is in fact 150 degrees. That's the value that we determined. Now, if I want to check it, I could go to my calculator, go into mode, I'm in degrees, arc cosine of negative root of 3, and I divide, got to close my parenthesis, divide by 2, and lo and behold, I do get 150 degrees. Okay, so here's the last kind of problem that you have. We want to be able to evaluate these expressions by sketching a triangle. Sine of cosine inverse of 1/2. First, I'm going to consider cosine. This means that the cosine of an angle is equal to 1/2. Is cosine opposite, adjacent, hypotenuse? What is the ratio using opposite, adjacent, hypotenuse for cosine? Adjacent over hypotenuse. So adjacent over hypotenuse. So 1 and 2. Adjacent would be 1, hypotenuse would be 2. So I'm making a triangle that constructs this problem. Could I find the other side? How? A squared plus b squared is c squared. So 1 squared plus b squared is equal to 2 squared. Or 1 plus b squared is equal to 4. So b squared is equal to 3. Square root of 3. This is the part where people get confused. Just focus on this. When you do cosine inverse or tangent inverse or sine inverse, what does that produce for you? Produces an angle, right? So what's your angle in this problem? It's on the board. It's a Greek letter. Theta. So cosine inverse of 1/2 will produce theta. Everybody agreed? So this expression becomes sine of theta because cosine inverse of 1/2 will give me theta. So this is just a fancy way of asking what is the sine of theta given this triangle? Sine, opposite, adjacent, hypotenuse. What do I have? Opposite over hypotenuse, so therefore you get square root of 3 over 2. So that's what that comes out to be. Yes? I just chose it to be there. If you want to choose it to be here, then the 1 would be here and the square root of 3 would be down here. Look at the next one. Sine, opposite, adjacent, hypotenuse. Opposite over hypotenuse. So opposite will be 4, hypotenuse will be 5. Anybody know the other side of the triangle? 3, because it's a 3, 4, 5 right triangle. So if I do sine inverse of 4/5, what will that give me? That's on the board. Theta. So this becomes cotangent of theta. What is cotangent in terms of opposite, adjacent, and hypotenuse? Cosine over sine, or x over y, or adjacent over opposite, right? So 3 over 4. Tangent of secant inverse of 3. What is secant in terms of opposite, adjacent, hypotenuse? Good. Hypotenuse over adjacent, because it's the reciprocal of what? Cosine. And cosine is adjacent over hypotenuse. So we have hypotenuse over adjacent. Can we find the other side? Pythagorean theorem. You get 2 roots of 2. So this becomes the tangent of theta. What is the tangent of theta then? Opposite over adjacent, just 2 roots of 2. And our last one. We sketch the triangle. Cotangent, opposite, adjacent, hypotenuse. Adjacent, 12 over opposite, which is 5. Very good. Henrik has memorized his Pythagorean triples. Good for you. So this expression becomes the cosecant of theta because cotangent inverse of 12 over 5 will produce theta. So the cosecant of theta is hypotenuse over opposite. Very good. 13 over 5. Nice work. That's your final lesson of chapter 7.